cancel, so it's just 38. 38 over 5. 5 goes into 38 7 times, so it's 3 left over. So it's 73.
No, the entrance?
Yep.
Oh, that's because of
Because of the flipped date.
Alright. Thank you, Jordan, appreciate it.
Yep.
For 102, wouldn't that be negative?
Yeah.
Negative 111 over 54.
Did you show the what's on the side?
I mean, I have under mine now.
Well, no, put it back, because I was running out of time and it looked like 3 hours. So there's,
I just know what we're, I just be dotting out wherever I feel like.
For 19.
yeah,
Well,
I was like fucking like 10 problems, I was running out of time, so I just had to fucking look at 2 back and forth.
171 minus 282 is 111 over 54.
Only one negative.
Which
Um,
makes sense.
Shit, it's complicated.
Negative 5 over 6 plus 3 over 2.
Oh. That was just fun, nothing like this.
Yeah, I'm not sure. One of those is right.
Did not like 109.
91, negative 2, 118.
That's what I got.
So,
Negative what?
Negative 2, 118.
Is it a multiplication?
Yeah, I probably
Yeah.
screwed it up.
It is?
well, that's probably not. Just trying to figure out how to do it. Because you're looking for how many gallons to fill it. 109 and 110 were both.
I did it, I got the right answer, but,
How'd you get that?
I don't know how to show it.
How'd you get
I was
that?
running out of time to do the last 10 problems, I was
It's
like,
like that. 'Cause you're looking
1/3
for
is the answer?
yeah.
Yeah. The full tank
You know, you
is.
got?
No, I got 6.
I thought it was 2/3 filled up and the total would be,
Okay,
2/3 is what they're looking for.
So I think that's
The
right.
full is the 15 over 4, 15 over.
Oh shit, I need to do myself.
Yeah, I would think shit on my phone.
I probably did the same exact thing.
Yeah. Here, so 15 and 3/4 is
Yeah, I'm pretty sure I did it wrong.
how much does it take to fill 2/3 of the gas tank? So this is full. So you're looking, you're trying to, you had to Google it to figure out what to do. I Googled 109, which is the same type.
Because I know.
Who'd you get for 101?
Positive, but.
10 and a half
I
gallons.
don't know, so.
Yeah.
So 2/3 of
Yeah, I just,
In the,
Yeah, I was super confused at first.
Oh, yeah, yeah.
because this should be negative right
Yeah.
here.
There was negative and positive and negative.
You did this one? Yeah. So when you learn how to
Make these a positive?
the Darius,
Supposed to stay negative.
I thought it was like, they both negative. That's it, see, we just subtracting this one. So that's when you multiply it, I get what you're saying. When you multiply it, but this one has a negative.
negative 7.
He did too, but I don't know.
Yeah, I think he forgot the negative right here.
Really?
I got 1/6, but I think I screwed it up.
That's why I had it first off, I broke it.
Yeah. He said he didn't have time to do all the
I
work.
just saved it like this.
You'd have 1/2 plus 1/3 times 2/3, then you do the multiplication.
Would you get 1/3? You got 1. Maybe that's where I screwed up.
See, I write them as a,
I don't know.
I don't know.
So for 3/8
Jordan explained that to me, I didn't know. I just told him.
Broke it. Okay, so
Yeah.
here's what I did. Okay, so now
So
I see what I did.
5 halves minus.
So it was 4, so it'd be 8 over 2, which would equal the negative 3 over 2.
Right, I got
And
that
then-
4. So
And
then
then
that's
doing
half
3/8
plus
divided by negative 3 over 2.
Right, so times
Do the
2 over 3.
multiplication.
What'd you get?
The 3's cancel out, that equals 2/8 or 1/4.
Wait, Did I do that wrong?
Because 3/8 divided by negative 3 halves is times, 3/8 times 2 over 3.
Yeah, so 2 over 3 would equal negative. So you just multiply across the top, so it'd be 6 over negative 4.
Which
You
is
simplify that down to negative 1/3.
2/8. Because the 3's cancel. 2 over 8, 1 over 4.
You do that multiplication.
I think so. Maybe not.
106, I got
3 times
96
2
over 124 over
6. 3 times 3 is 20.
Negative 1/3.
Oh, yeah.
Negative 1/3 times 2/3. So it'd be negative 2/3 times. Just there, and then it'd be plus 1 over 2. So it'd be 18. Addition. So you have the common bottom.
Right.
Common denominator, which made it
So 9.
9 plus negative 4. So 5/18. That's what I did.
Yeah, I'm not sure.
What'd you get for 97?
97, probably something else, 7.
He got 1 over 30. What did you do?
I don't put that much.
I think that one needs to go.
Yeah, I think so too.
What'd you get for it?
Kim,
5 over 6.
huh, what'd you get from there? Negative 3 and 4.
Different numbers.
Yeah, everybody's got a different answer.
Yeah, I got 3
Can we throw 97 up on the board?
97?
Yes, sir.
And 106 too, please.
I felt like
Yeah.
so much when I did it. I was like, oh, yeah, yeah. You, I broke it down.
97 and 106 as well. Okay, yeah, I'll do 97 on the front.
What'd you get?
97, I got 410. Yeah, 410.
Okay, so it's 5:34, we're officially on our 10-minute break, but of course the serious student will continue to look at the whiteboards.
Oh, break time.
So, class officially resumes 5:44.
One more talk, one
Not a mistake.
Yeah, well,
Oh, yeah, negative 15 plus 14. Right, because negative 15 plus 14.
What was the original problem?
Anybody who wants to see one, actually get a card and then
What'd you get for 97?
After looking at all those problems, I decided to write numbers down. I'm like, what the heck? 97, I gotta write, I was like, this isn't even the question.
I see where I went from 8 to 10.
I haven't heard the same answer yet.
yeah, what was it?
Yeah.
101.
Then you use 18.
Nothing's wrong.
Yeah.
I just feel very needed.
It's 5, 6,
So again, we're on our break. Anybody needs to
And then
take care of any business?
7 or 16?
Trying to do it now.
For me,
7 or 12.
I
I think it was 5.
I
We're still working through them.
I know that right now.
There's some dorms that have full kitchen, full living room.
So 5 more minutes left of break, anybody needs to
Just a room with a bath.
take care of any personal business?
That's a draw.
It's okay.
I'm sorry,
Continue,
don't duck your
continue.
point.
Continue.
I didn't know, I'm sorry. I forgot.
Yeah.
I swear.
It's okay.
You too.
Oh, no, not a tablecloth.
You're so animated.
Yeah.
I was like,
Go back home.
I thought I was.
Finish this class, come home from
Yeah, I went to go look at some calculators before I came, and I was like, alright, I got 2 hours.
You know what this looks like? It's like a food, like there's some, the difference is here, like literally made this like barbecue ramen and some, it's like all that. Literally.
So it's like, it's good to explore this, like, couple weeks, you know,
Like, you eat home.
but we stay here, sometimes we just want like Chinese food,
Yeah.
just a good old buffet.
What's the deal? Pull it out there. Always find it.
Maybe station somewhere else, for kids, 40. They just told you that, or was it my option?
If I wanted to, I can request to go to the church, and you get approved, but honestly, like, this is so less and this is like free cash compared to probably shipping it. And they know the way there, they want to focus on that way, you don't have time to take care of it.
That's the start.
97?
Yeah.
Get that. Plus. Oh, yeah, 'cause this is 10. 10 minus 4. You gotta get that common denominator. Minus 4.
I think it's about time to resume. I think I wrote the wrong time down, it doesn't matter, 10 minutes. I'd like to resume if I could. First thing I'm gonna do is, for the last time, I hope, put the whiteboards back, and hopefully it'll be done by enthusiastic volunteers afterwards. First, this one has breaks, which most of them appear to be set. So they come up, and on the back.
Can you help?
Nope. Okay, and it goes back into its slot. And the next one gets nestled cozily into it. So again, the next thing to really point out to you, especially Momiko, Momiko, do you know how to go to your Leo website
Yes, I know
for
it.
this course? Now, if you go to your Leo website for this course, and you go to content, then you see this come down, and what I'm going to do is first click on this choice, your in-class videos from a year ago, and you see a complete set of A1 through A15 from Okinawa a year ago. But you guys are now on board, and now we have your in-class videos for this year, and these are the videos from 48 hours ago in this class. So Mariko, especially, you should watch these 3 videos for the classic and this. Anybody else wants to see anything else? Tonight's videos will be up there as soon as possible, which will usually be about Saturday. And you can check them out too. But as well as these videos, you want to be sure to learn how to go to YouTube, which has thousands of videos on math, most of them short, 3 to 5 minutes. And in the search box, type in the topic you're interested in, such as the order of operations. And you'll find lots and lots of videos to help you, and get one to suit your personality. And the ones put out by Khan Academy seem to be especially popular. So by all means, go to the YouTube videos for things that are causing you trouble. Get different slants on them. I'll do problem 97 now at this point. Number 97. And the problem is 1/2 plus 3/8 over 5/2 minus 4 times 2/3. Okay, please help me to see if I copied it reasonably well. I need a confirmation. It's decent. It's decent. That's better than I usually get. So first I'm going to do some side work, and I'm going to approach this item from the side. So what I have is 3/8 over 5/2, and I'm going to call it 4 over 1. Equals 3/8 is a single fraction, so I'm happy. But now 5 over 2 and 4 over 1 have to be combined into a single fraction. And what's the common denominator going to be for denominators of 2 and 1? 2. So we have 4 ones equals something over 2, which is going to be 8. So this changes to 5/2 minus 8/2. So we have 3/8 on the top, and on the bottom we have 5/2 minus 8/2, which is a net of what? Negative 3/2. Now we go to dot dash dot notation. 3/8 divided by minus 3/2, which is equal to 3/8 times minus 2 over 3. Flipping it. Now we see some cancellations, that this 3 goes with this 3, and this 2 goes with this 8, and we get a net of minus 1/4. So this item in the box reduces to minus 1/4. So I'm going to rewrite the original problem, it should be straightforward now. We have 1/2 plus minus 1/4 times 2/3. So we have two operations, addition and multiplication, so we do the multiplication first. So we have 1/2 plus, well, we'll worry about the sign later. So we multiply across the top, and we get a 2, and we multiply across the bottom, and we get a 12. And this is going to be a minus sign. So, now we have to put these over a common denominator as well, and that common denominator is going to be 12, agree? So we have to do some side work. 1/2 equals something over 12, which is going to be 6. So we have 6 over 12 minus 2 over 12, which is 4 over 12, for the answer of 1/3. Right. So it's all there. I think I heard 1/3 from one person, and a multitude of different answers from the other persons. So that one's done. Now, could you take out your assignment sheet one more time? Okay. Now, to return to the back side, and Emilio, on the back side of the assignment sheet, could you read the cartoons, the balloons in the cartoon at the bottom, the very last one on the bottom? Could you read the cartoons? I need help.
Okay. I need help answering all these questions. Okay, read the chapter, then we'll answer the questions. Read what?
Okay, good. Now, I'm not gonna call out anybody, but one person jumped right into the homework and wasn't able to do a problem that they would have been able to do if they had actually worked the examples. So it's true to do it this way. That's good. Okay, now, are there any remarks, comments, suggestions? We're going to put A1 behind us now, and I'm going to do the presentation for A2, which is section 1.4. There was a request for problem 106 also. I'm just going to postpone that. I don't like mixed numbers myself. I don't think it warrants class time at this moment. If we have extra class time at another point, I'll do it. But it is a straightforward problem, not a class difficulty, like 97. It's understandable. I'm going to write a number on the board, and I'd like you to tell me if you have any lack of understanding of what that number is. Is there any trouble with anyone in the class on that number? Is everyone comfortable? They know the number that I've written. Now I'm going to write another number on the board, which is different from the first number. This is the number I'm now going to write. This number is called the square root of 3. This number is not 3. This number is called the square root of 3. The square root of 3 is a number different from 3. And the square root of 3 is defined as a number that has the property that if you multiply it by itself, the result of that multiplication is 3. So this new number is called the square root of 3. And it's a number that if you multiply it by itself, the result will give you the number in the box. So let's test your understanding. Square root of 7 times the square root of 7 is? Well done. Okay, now I do not know what the square root of 1192 is. I have no idea. But if I multiply it by the square root of 1192, what am I going to produce? 1192. So that's what we mean by a square root. Okay, now, we have numbers that are known as rational numbers. Some of you think no numbers are rational. And those are numbers that can be expressed as one integer over another, such as 3/4, 5/11, 2/3. These are all rational numbers. They're expressed as one integer over another. Now, rational numbers have a signature that if you transfer them to a decimal, then that decimal is either terminating or repeating. So let's express 3/4 as a decimal. What does it become?
0.7.
Now, remember that this line means what operation? divide. So ask your calculator, what is 5 divided 11?
0.45.
So again, it's a repeating pattern, is it not? And 2/3 is also a repeating pattern, 0.66666. And it goes on forever, but the pattern repeats itself. So rational numbers which come from one integer over another as decimals will be signaturized as a terminating or repeating fraction. That is not true of irrational numbers. Now, our most famous irrational number is if you take a circle, the circle has some distance around, which we will call C. The circle also has some distance across, which we'll call D. And for any circle, no matter what size, if you divide C by D, you always get the same number. It came with our universe. We didn't choose, we would not have chosen this one if we could have. But that number, we give the symbol pi to. You say, why don't you just write it as a number? Everybody knows that pi is equal to 3.14, 82967432. And I can't stop, or it's not pi. Because pi is an irrational number, and the signature of irrational numbers is that they are an infinite, non-repeating decimal. They never terminate, and they never repeat. So now I have my choice. If I want to write the correct value of pi, I can either write an infinite string of digits, or I can use the symbol pi, which stands for that infinite string of digits. I've made my choice, and you can make your own choice. So this is why we use the symbol rather than any actual number, because as soon as you truncate it, you've lost precision. It's no longer pi. So we designate it by its symbol, pi. Now, quite clearly, the square root of 3 is also an irrational number. Now, because it's an irrational number, and to express it precisely, I would have to give an infinite string of digits. I choose to represent that infinite string of digits by the label radical 3, which stands for the infinite strings of digits. And if I truncated that infinite string of digits, it would no longer be radical 3, as you can testify for yourself. First, you say that's not true because my calculator can tell me what the square root of 3 is. So go ahead, ask your calculator, what's the square root of 3? 1.73 is enough. Now, if 1.73 is the square root of 3, then 1.73 times 1.73 should give you back what? 3, agreed? That's what we mean by square root. So go ahead, multiply 1.73 times 1.73. And you get 2.99. So, indeed, 1.73 is the square root of 2.99. It's not the square root of 3. So you cannot make these approximations and truncations without losing accuracy, which is why we keep the symbol radical 3 in the problem, because it stands for the infinite strings of digits and it is exact. And it is true for most other square roots as well. For example, the square root of 1 is 1. The square root of 2 is one of those infinite digits. Square root of 3 is one of those infinite digits. For the square root of 4, we happen to be lucky. Turns out to also be an integer, which is what? 2. And the square root of 9 would be the next one that we're also lucky for. All the ones in between are irrational numbers. Now, if you work a problem on a test and you reduce it to an answer, 6/8, do you receive full credit? No, because not. Why? It's not reduced to lowest terms, agreed? So you have to reduce it to lowest terms, so you come in by a 2 and you get 3/4. Quite similarly, if you put a number, square root of 8, as your answer to a problem, you will not get full credit because it's not in lowest terms. And now we're going to find out what we mean by the lowest terms for a square root, and that will be found by the following process. First, I need some help So what I'm going to do is make a list of perfect squares. 1 squared is 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared, 25, 6 squared, 36, 7 squared, 49, 8 squared, 64, 9 squared is 81, and the hard one, 10 squared is 100, and 11 squared equals 121, and 12 squared equals 144. Now, these are the perfect squares. Similarly, they have a list of perfect square roots. The square root of 1 is 1, the square root of 4 equals 2, the square root of 9 equals 3, the square root of 16 equals 4, the square root of 25 equals 5, the square root of 36 equals 6, the square root of 49 equals 7, the square root of 64 equals 8, the square root of 81 equals 9, square root of 100 equals 10, square root of 121 equals 11, and square root of 144 equals 12. Now, we're going to use this list of perfect squares so often in this course that I'm going to save you hours out of your life looking it up each time you need it by requiring that you memorize it. Now, so let's all say together the perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 140. Okay, now you try it without me.
1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144.
That was excellent. Keep going. Okay, one more time.
1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144.
Okay. Now, let's go back to our problem of the square root of 8 and find out why it's not yet in lowest terms. First, I'm going to write down my list of perfect squares because I'm going to need them. Now, it's a principle that if I have the square root of 36, you could probably tell me what it is. And what is that number? 6. So we know it's equal to a 6. Now, I'm going to express 36 as 9 times 4. Does anyone have any trouble with replacing 36 with 9 times 4? It's approximately the same. So now on the board I have two operations. I have the operation of multiplication and square rooting. Now the natural order, which we've already done, is you do the multiplication, you get a 36 and come down to a 6. But it's indifferent. You don't have to do the multiplication first and the square rooting second. You can do the square rooting first and the multiplication second. This is also the square root of 9 times the square root of 4, where I've done the square rooting first, the multiplication second. Now, what's the square root of 9?
3.
Square root of 4?
2.
We get the same 6. So you have this freedom. When your problem involves both square rooting and multiplication, you can do whichever one first you get. Now this has a general statement that the square root of two products, A times B, is the same as the product of the square roots. General sense. Now this shows us why we can improve upon the square root of 8. Because I want to replace 8 with two factors, one of which is in this list. And I want to replace it with the largest number that's in this list. So I start at the bottom of the list and I go up till I come to a number that's less than 8. The first number is 4.
Got it.
Try and add a file.
The first number is 4. So is 4 a factor of 8?
Yes.
So I can replace 8 with 4 times 2. Now with my principle that the square root of AB is the square root of A times the square root of B, this becomes the square root of 4 times the square root of 2, agreed?
Yes.
But the square root of 4 is an integer, is it not? So this becomes 2 times the square root of 2. So we found that the square root of 8 is the same number as 2 times the square root of 2, just like 6/8 is the same number as 3/4, but 3/4 is in lowest terms. And 2 square root of 2 is in lowest terms because the smallest number possible is inside the square root sign. That's what we mean by lowest terms for square root. So I'm going to do another example for you. Let's take the square root of 50. Now I want to start in this table and go up from the bottom to the first number that's less than 50 and keep going till I find a factor of 50. Does 49 divide into 50?
No.
Does 36 divide into 50?
No.
Does 25
Yes.
divide into 50?
Yes.
So 25 times 2, but this breaks apart. The square root of 25, square root of 2, so the reduced number is 5 square roots of 2. So this is how you reduce square roots. So I'm going to pass out a worksheet that we will use this evening, and you can drop it in a chair, which I'll put right here on the way out, if you want to have your children also use it later, or you can take it home and study it for the test, or do anything that you care to with it. This is not an assignment, this is just a worksheet from class.
Thank you.
Hi, sir. So, can everyone please do number 17? 17. Oh, no. Did I Xerox the one with the answers? How many have answers? You wouldn't say so, you did, would you? Maybe I got lucky. Okay, I got one page with the answers. Okay, number 17. The square root of 20 by using this principle. So I'll illustrate how you do it one more time. Square root of 20. Start with this list, you go up to the final number, less than 20. 16 divided into 20, no. 9 divided into 20, no. There's 4 divided into 20, yes. So this is equal to the square root of 4 times 5, which is the square root of 4, square roots of 5, which is equal to 2, square roots of 5. Okay, can everyone please do number 18? So Momoko, do you have an answer for 18? Momoko is the lady in the back, so that could be confusing. Sorry about that. Why don't we call you just, I don't read the book. Momoko is, the answer is?
5 square root.
Right. Now the professional way to say this is 5 root 2.
5 root.
5 root 2. Okay, Jordan, number 19. Number 19. I'm sorry, number 20. Did we do 19 yet? No.
No.
Okay, 19. Sorry. So we go up to the first number less than 80, which is 64. Does 64 divide 80?
No.
Does 49 divide 80? 36. 25. Does 16 divide 80?
Yes.
Yes, use it. 16 times something. Calculators included. 16 times 5. So that you replace it by the square root of 16 times 5, which becomes separately the square root of 16 separate times the square root of 5. So final answer, Jordan, is?
4 root 5.
4 root 5. All in favor? Okay, Darius, number 20. But the 12 on the outside times root 1, let's do it in steps. The problem is to do this, we're at 12. So Darius, what would our first step be? We want to put this template up, and we want two numbers. So we want to divide 12 into two factors, one of which is on this list. So what would the two numbers be, one of which is in this list? 4. What would the other number be? Because remember, you're replacing 12. 4 times what? 3. So you have to still see 12. Now notice, when I write 2x, or when I write 2y, I really mean 2 times y, agree? But we don't bother to write the times sign, we just write 2y. When I write 2 root 3, I really mean 2 times the root 3, but we don't bother to write the times sign, we just write 2 root 3. Okay, so Emilio, what about 31? So start at the bottom, first number smaller than 250, see if it divides.
Oh,
Go up
you mean
to
21 or?
number 21.
Oh, it's
And your answer is 5 root 10. So how many people agree with 5 root 10? So I'll do this last one. Root 250 equals two things. One of which is on this list, the largest one on this list. I start at the bottom. Does 144 divide 250? No. 121? No. 100? No. 81? No. 64? No. 49? No. 36? 25? Yes. 25 divides 250. And you can check your calculator each number. Square root of 25, square root of 10. Answer 5 root 10. Okay, anybody, number 22. Everybody, number 22. First time we come to a harder one. Well, you can't leave it at 4 root 12 because root 12 reduces. So you obviously didn't find the largest number the first time, so you paid a price of doing it in 2 steps. You missed something.
8 root 3.
We have a winner. 8 root 3. All support 8 root 3. 8 root 3. Now, Jordan missed it. So he ended up having to pay the price of doing one more step. He ended up with a root 12, which will further reduce. It's no big deal. It's just like reducing fractions. If you don't do it in 1 step, you can do it in 2 steps. Now, I'll do 23 because it's a new type of problem. And it's 7 times root 28. So I'm going to write 7 times root 28. Now I'm going to do some side work. That the root of 28 is a root of 4 times 7, which is a root of 4, root of 7, which is equal to 2 times the root of 7. So this is 7 times, and instead of root 28, I'm going to write what it's equal to. 2 times the root of 7. Now, going to multiply that first 7 and 2 together. Absolutely right, final answer, 14 root 7. So that 7 in the front is just along for the ride. It goes all the way down, all the steps, and at the end, you do a final multiplication. So number 34 is, Kelly, what do you have for 34, final answer? The number 5? No, it's going to have some other parts to it. So what was the first thing you did?
I broke down the square roots and 5 and I got 5.
You broke down 52, agreed? You break 52 into two, we're doing 24?
You told me
You said
34.
34?
Yes,
Yeah, you
sir.
said 34.
So I jumped. That's why I said.
Well, I'm impressed. You did 34 right, and I haven't even shown you how to do it. You don't need me. So we can skip all that. I apologize. Could we please do 24? I got to focus. Don't really have it tightly together at the moment. 24, what are you laughing at? You never have it tightly. So 24. So anyone except Kelly, she deserves a problem off. You have it, Kelly, anyway, Kelly, 24? What do you have?
Oh, I don't have it. I'm
Okay.
sorry.
Alex,
6 square root of 13.
6 root 13. Everybody, anybody else get it? 6 root 13. Anybody have a hesitation on it? Anybody want to see a step? Okay. Okay, so what we have is 3 root 52. 3 times the root of 52. So in my side work, the root of 52 is going to be 2 numbers, one of which is on this list. 49 does not divide, 36 does not divide, 25 does not divide, 16 does not divide, 9 does not divide, 4 does divide. 4 times 13. So this becomes root 4 times root 13. It becomes 2 times root 13. So now we bring that back up here and replace it. So 3 times 2 times root 13, 6 root 13. So those are the steps we put in. Now, this equality goes both ways. If you have a product that you're taking the square root of, you can break it into 2 separate square roots. But it goes the other way as well. If you have 2 separate square roots, they can be expressed as 1 square root. So I'll do for you number 25. So the square root of 7 times the square root of 6 can be expressed as the square root of 42, where we use the rule backwards. The square root of A times the square root of B is the square root of A times B. So you can use the rule frontwards or backwards. So the square root of 6 times the square, why would you ever want to do this? I didn't make right. Square root of 6 times the square root of 7 is the square root of 42. So everybody, what's the answer to 26? Square root of 19 times the square root of 3 is? Root 57. Okay. Now make me proud. 27. The square root of 6 times the square root of 6 is? 6. Remember our original definition of square root. Original definition of square root Square root of 3 times the square root of 3 was 3. Square root of 7, square root of 7 was 7. Square root of 1192 times the square root of 1192 was 1192. That's the definition of square root. Okay, anybody? Square root of 5 times square root of 5 is? 5. Is 5 by definition of square root. Okay, now, what's the answer to 29? Emilio, the answer to 29 is? Square root of 3 times square root of 6 is what?
Square root 20, or square root 18?
Square root of 18, that's perfect, as long as you don't want full credit.
Oh, yes.
But is square root of 18 reduced to lowest terms? Negative.
3 square root 2.
3 square root of 2. So, this has a couple of steps in it. Square root of 3 times the square root of 6. So, square root of 3 times the square root of 6 is clearly the square root of 18. But 18 is clearly also the square root of 9 times 2. So this is also the square root of 9 square root of 2, which is 3 square roots of 2. So you'll have to reduce it to lowest terms, even after you find that. So therefore, what about 30? The answer to 30, Jeremiah B, the answer to 30 is? Two root 6. All in favor? 2 root 6, by the same sequence of steps. 2 root 6. And one more practice one. The answer to 31, by the same sequence of steps. So Camille, do you have the answer to 31? Chanel. Chanel. Got it, apologize. Chanel, the answer to 31.
1 second, sir.
Hi.
2 square root of 13?
Perfect, 213. Derek, do you have an answer for 32? A harder problem. $32.
To root 10.
Excellent work. Nice piece of work, sir. Nailed it right on. Okay, now, what is often true of multiplication is always true of division, because multiplication and division are really the same operation. So let's establish the equivalent for division in the following way. If I want to take the square root of 36 over 4. Most of us would simply divide first, which means it's the square root of 9, and we get an answer of 3. However, you have your choice when you have these two operations, division and square rooting, and you can do either one first that you care to. So let's do the square rooting first. This is the square root of 36 over the square root of 4. And the square root of 36 is, square root of 4 is, and we get the same 3. So you have your choice. When you have the square root of A over B, you can take the square roots first and do the division second, which Kelly already applied. Now this is very useful in the first example that I'll give you. 75 divided by the square root of 3. Now, you're going to have a lot of fun with this problem because both of these are irrational numbers. So the square root of 75 is going to be an infinite string of digits. So you better start writing it down, it's going to take a while. Then you have to divide it by the square root of 3, which is another infinite string of digits. That doesn't sound like a simple calculation. However, if we use the principle that we've just realized, this can be switched to being the square root of 75 divided by 3 first, which now becomes the square root of 25, which is a simple 5. Now, which is the way you prefer to do the problem? To divide one infinite string of digits by another infinite string of digits, or to switch the order that you do the square rooting and the dividing? Choice is yours. I've made my choice. Okay. So let's apply this principle to number, no pencils, 33. The answer is 3. Because what we're going to do is the division first. 54 divided 6 is, square root of 9 is 3. Kelly, could you do 34 for us?
5.
Well done. And also done on the board. Okay, everybody, 35. Pencils permitted. Pencils permitted. I don't worry about it. Mercedes, you have an answer. What is it, please? 3 root 5 wins. First it becomes the square root of 45, agreed? But then you use the list of perfect square roots, and you find you can use a 9 times 5. Okay, the last one of this type is number 36. 36. So Jeremiah C., do you have an answer for 36?
Yes.
Please.
2 root 5.
Winner, 2 root 5. All in favor? Okay, we're getting good. Now I'll do the next one for you because it has something new. Minus the square root of 96 divided by the square root of 2. So minus the square root of 96 divided by the square root of 2. So that minus sign is just along for the ride. It doesn't affect anything, and it will be there in your present answer. So this is minus the square root of 96 over 2, which is minus the square root of 48, which is equal to minus the square root of 16 times 3, which is equal to minus 4 root 3. So now everybody do number 38, which is done much the same way. 38, same as my age.
Who's the next number you wanted us to do?
Did I do this one wrong?
No, the next number you asked us to do.
38.
Okay.
38. Dylan, do you have an answer for 38?
5 root 2?
No? Anybody else? Negative 5 root 2. Right, slip of the pen there. Minus 5 root 2, all in favor. Okay, now I'm gonna write a calculation on the board, and I don't want you just to jump into the answer. I want you to think it over and decide that you're sure you're right before you voice your answer. Now, give it the thought that it deserves. 2x plus 3x. is equal to what? 5x. Guys didn't have any trouble with that one. Let's try a harder one. 2p plus 3p. No trouble with the slightest. Okay? Very difficult one. 2w plus 3w. Not bad. Okay, 2 square roots of 7 plus 3 square roots of 7. 5 square roots of 7. 5 square roots of 7, right? It works just like the ones above it. 2 apples plus 3 apples are 5 apples. Okay? So with that in mind, no pencils, what's the answer to 39? Not bad. The answer to 40. Excellent. No pencils continued. The answer to 41.
Negative root 13.
And 42. And the answer to 43. Make me proud. The answer to 43 is? 2 root 5. 2 root 5. 1 root 5 plus 1 root 5 best be 2 root 5s. So let's look at these two different problems. Root 5 times root 5 is equal to 5. And root 5 plus root 5 is equal to 2 root 5. Because there are imaginary ones there, you can put them in there if it makes you better. Okay, now let's try a harder problem. Root 6 plus root 6 is 2 root 6. No trouble there. Okay, now 43. Momoko, what is the answer to 43, please? Oh, I did that one. To 44, sorry, 44. 2 root 3. Root 3 plus root 3 is 2 root 3. Hi. Okay. Everybody, 45. Good. And 46. Good. You guys are getting very streamlined. Now I'm going to write another difficult problem on the board. And again, think it over. Don't jump into your answer. But what is 2x plus 3y?
6x1. Or 5x1.
Make up your mind. 6xy, 5xy. Any other answers? Answer is 2x plus 3y. It's one's an apple, one's an orange. They don't combine. 2x plus 3y is equal to 2x plus 3y. If you have 2 bicycles and 3 cars, what do you have? 2 bicycles and 3 cars. If you have 2 apples and 3 oranges, what do you have? 2 apples and 3 oranges, agreed? So let's try something harder. 2p plus 3z is equal to?
2p plus 6.
Let's do something sure. 2t plus 3w is equal to? 2 to the square root of 5 plus 3 square roots of 7 is equal to? 2 square roots of 5 plus 3 square roots of 7. They're not like terms, they don't combine. One's an apple, one's an orange. Right? So with that in mind, what then is the answer to number 47?
3 root 5.
Anybody else? What's the answer to root 5 plus root 20? Nobody's falling for it. Root 5 plus root 20 might be just root 5 plus root 20, but it might not, because root 20 is not yet in lowest terms. So we're not sure until we put root 20 in lowest terms. Root 20 is equal to root 4 times 5, which is equal to 2 root 5. So the problem becomes root 5 plus 2 root 5. And Jordan, the answer is 3 root 5. And 48, please.
4 root 3.
Who said that? Well done, 4 root 3. We're okay on that. So Chanel, 49, please. Root 50 minus root 18. This will be a little thought. Root 50 minus root 18. Dylan, your answer, please.
I didn't get it, I'm not sure.
Okay, hanging out. So Chanel, how are you doing?
Almost there.
We're almost there. So we have to reduce both of them and then see if there is any similarities. I guess we need a list of perfect squares. Can someone help me?
Two root two?
2 root 2 wins. 2 root 2. Anybody care to see some steps? Okay, so this is root pi, 50 minus root 18. So root 50 can be composed going up the list to the first number smaller than 50. 49, no. 36, no. 25, yes. So this is root 25 times 2, which is 5 root 2. Now 18, let's go up the list. 16, no?
No.
9,
None,
yes.
yes.
Minus 9 times 2, which is minus 3 root 2, for a final answer 2 root 2. So those are steps. Okay, everybody, the next problem, 50. Same as my IQ. 63 minus 28, it's done exactly the same way. So you need this list of perfect squares. George, you do this homework ahead? No, you're fast. Well, half. So root 63 minus root 28. Root 7. Okay, Jordan, your answer is?
Root 7.
Anybody care to see Jordan show some steps? Any requests?
What'd you say?
1
Root
root
7.
7, root 7.
No.
Last call, any requests for steps? Gone. Okay, now, number 55. Number 55. Root 75 plus, did I say 55?
Yes, sir.
Thank you.
Yes.
Very good. No, no, they're clones, people are trying it. But what was it anyway, said?
11 root 3.
Well, let's see if anybody agrees. Anybody support 11 root 3? Nobody supports it, sir. Chanel, you have an answer for that 155?
I don't.
No.
6 root 3?
11 root 3.
6 root
11 root 3.
11 root 3?
Yeah,
right.
Anybody care to see Emil, you all go through some steps?
Yeah.
Oh, here's a request, Emil. Now, when you come up here, you're teaching. You're not just doing minimal work like you do for yourself, you're doing the steps that the class needs to see, which means the more steps, the better.
Square root 25 times 3 plus 2 square root 4 times 3 16 times 3. So square root of 25 is 5. 5 times 3 is 15. Eraser.
So use the eraser in the middle. You put the pencil down first. Pick up the eraser. Pray.
Oh, that's cool.
$8,000.
And square root of 2, or square root of 4 is 2, so 2 times 2 is 4. And square root of 16 is 4, so 4 times 2 is 8. And from right there, you do 15 plus 4, well they're all the same square root, so 15 plus 4 is 19, square root of 3 minus 8 square root of 3, and you come down to 11 square root of 3.
I appreciate, very excellent teaching presentation. Putting in steps we can follow. Very well done. Okay, the last one of this type, number 67. 67, who's done? All right. And Jeremiah B, your answer is? Oh, okay. Didn't mean to slow you down. Alex, answer please.
A square root of 2 minus 5 square root of 3.
What was the first thing?
A square root of 2.
So close you can smell it, but no. Very close, sir. Little typo, probably sign mistake someplace. Chanel, yeah?
Wait, what did he say?
You have an answer?
Wait, what
Well,
did
it
he
doesn't
say?
matter what he said. What do you think?
20 root 2 minus 5 root 3?
Okay, we have a winner. 20 root 2 minus 5 root 3. Anybody want to see some steps? Yes, there's a request. Did you? Yes,